Welcome to our community conversation session for Technomatics Plant Simulation. I'm Taryn Blake, our Community Engagement Program Manager, one of them, and I'll be your host for this enablement session. And today, as you can see on the screen, we are talking about optimizing simulation models with the GA Wizard. So let's jump in. And as many of you know, our presenter for the series is generally Mr. Steffen Bangsow, who is a freelance simulation expert. He's been doing this for many decades. We appreciate him and his expertise. And he does have 5 books on plant simulation. I believe he's working on his 6th book, and he is definitely one of our leading contributors here for our Siemens PLM community. So that is it for my introduction. And Steffen, feel free to steal the screen.
Today, I want to show you how to use the genetic algorithm wizard in plant simulation. And to start with, I want to create a scenario, and the scenario needs to be a little bit more complex so that the genetic algorithm can find a solution. And so this is the first difficult point if you want to use the genetic algorithm. Sometimes it doesn't find optimum, because if you have not enough stochastic elements inside your model, then each simulation run gets the same result, and so it's very hard to find an optimum in your simulation. And so I create a scenario. I have some stations. I have a station M1, and this station M1 has a cycle time, processing time of 1 minute. And I have a failure availability of 90% and 25 minutes MTDR. And then I have a buffer for decoupling. This is my buffer B1. And then I have a second machine, M2. M2 has again 1 minute processing time. %90 availability. 25 minutes MTDR. Next buffer. Buffer B2. For decoupling, and then parallel station. M3. My parallel station should have 5 places. Processing time 4 minutes. And only 60% availability with 1 hour MTDR. So our buffer has some work to do. Then I have next buffer. B3. And finally, one machine M4. Again, 1 minute processing time. Failure 90% and 25 minutes MTDR. Okay, so it's quite easy. I need to train. So this is my scenario. And now I need a question. And I have first I have a target throughput. Between 40 and 45 parts per hour. And I want to know the minimum buffer capacity. B1, B2, B2. So it's a little bit more complex. Target throughput. Yes, if you want to do this, you need to create a lot of experiments, and I want to use a variable here. I name it fitness value, and this should be the number of places in the buffers we need. And to calculate this, it's a little bit more complicated. It's easy to add all the capacities of the buffers B1, B2, and B3, and calculate a fitness value for this. But I need to consider this this condition. Each solution with a throughput lower than 40 and higher than 45 should be not valid. And this I can make using a penalty value. I can say, okay, I use 1 million as penalty value, and so this I mark these solutions as not valid. And so I need a method to calculate this. And I use the ANSYM method to calculate this value, this fitness value for my observations. And so I take a method and I name it ANSYM. And today it's not a lot of lines of programming. So I need to define the cases for my penalty value. For instance, if drain dot stat throughput per hour, it's lower 40, or drain stat throughput per hour, it's okay, this is lower than 40 and greater than 45, then my fitness value is 1 million. You can also use -1, 0, some value that is shown that's clearly not valid as a solution for this case here. Otherwise, the fitness value is the sum of all capacities. Okay, this is my fitness calculation at the end of the simulation, and so I need to set an end for the simulation here. For instance, 50 days. And the next step would be, if you don't have access to the genetic algorithm, would be to take the experiment manager, tools, experiment manager, and experiment manager. Is it? And then I hold down the shift key and drag the buffers on the experiment manager. And then I need to select the input value. This is capacity. Okay. I take the same for B2, capacity. Okay. And then B3, capacity. Okay. And this will be a multi-level experimental design because we need to change several values here. We need to change the value from capacity B1, B2, B3. And okay, I need the output value. Output value should be here the fitness value. Okay. And then I can oh, moment, it's the wrong screen. So it looks like in the experiment manager, and now I can define steps. Lower level, I want to check 1 to 100. Increment is 1. 1, 100. Increment is 1. 1, 100. Increment is 1. Okay. So, and now Blend Simulation brings an error message. Do you want to generate the experimental design? And then 1 million experiments will be executed. 1 million experiments, it's a lot. And so this approach may be not the right one, and this is a quite simple scenario, and it may be much more complicated. And one way to save a lot of time and get a quite good solution in a much shorter time is to use the genetic algorithm. And so I don't want to create 1 million experiments, and I want to go another way. And so I need first to add the genetic algorithm, the GA wizard to my class library. You will find this manage class library and then libraries GA wizard. Okay. And then you find the GA wizard here in your class library. I take the GA wizard. I don't need the experiment manager. The first step is to describe your optimization. And the first is you need to set an optimization direction, minimum or maximum. In my case, I want to find the minimum buffer size for B1, B2, B2, and B3. And so the optimization direction is minimum. I let this values here. You can read a lot of books if you want to know more about the backgrounds of the genetic algorithm. Next, I need to define some optimization parameters. And we can use here one shortcut. I close the GA wizard, and then it's the same like for the experiment manager. You can hold down the shift key and then track the buffers on the GA wizard. Okay, it's the same here. I need to select the parameter I want to optimize, and this is capacity. Okay. Then the same for B2, capacity, okay. Then B3, shift, hold down, and capacity, okay. And so you can define the entrance data and the fitness value. You can also just track on the GA wizard without holding the shift key. And then this will be the fitness value. Okay, let's have a look. So optimization parameter. So now you have a table, and it's already the parameters already are inserted here. Parameter is V1 capacity, and now we need to set the same like in the experiment manager. We need to define lower bound, upper bound. Upper bound should be 100, and increment is 1. Upper bound is 100, increment is 1, and here's the same. You can also use 1,000, 1 million, what you want. Okay, then you can close this table. Or I click apply, and then I close this table. So next is fitness calculation. You have two possibilities. One is by table. So fitness value is already included here because I have tracked it on the GR wizard. Another one is by method, and by method you need to return a value but it's quite the same like I done it here with the enzyme method. I used a method to calculate the fitness value, and it may be much more complicated like this one. Okay, and then you have statistical reliability. It's I guess you know this. If you have some stochastic influences like here the failure or the availability, you should make more than one replication of an experiment. And so we need to set here a number, for instance, 5, how many experiments should be done per experiment, how many replications you want to do. Okay, and then you can start some optimization run. This takes some minutes, so I reset and start this. It still takes time, but it's less time than you need to make 1 million experiments. So it's now my 5th generation. It should be the last one. Okay, now it's finished. You have a tab evaluate, and there you can show, for instance, the evolution performance graph, how it finds the best solution after the 3rd generation. He has already no better solution anymore, and so it's enough for this kind of evaluation to have only 3 generations instead of 5. So, and here, okay, the best individuals best show here. So with best individuals, you have some solutions. The best solutions here with a fitness value of 179. and chromosomes means how it changes, how is the setting of the capacity of the buffers. And here the best solution is with a buffer capacity for B1 of 11, 97 for B2, and 71 for B3. And there's an offspring diagram here, and this shows all the solutions they find here. It's not okay. It's not so. It's because I have 1 million as a penalty value, and so the diagram doesn't show a nice progress. If you have only a penalty value of 1000, then it looks better. I make another try. Just for visualization, I change the penalty value to 1000. And then the development of I need only 3. And then I run it again. Okay, you can find a lot of explanations how it works. You can ask your large language model you use how it works internally. It finds a good solution. It doesn't mean it finds the minimal solution. I see here it's now find much better solutions. It starts from a certain solution and looks for the next better solution through changing the capacities of the buffers. And if you have a solution that it's fine and looks good, then you can start to create your own experiments, and you have save a lot of time. Okay. Now it's my third generation. Okay, so again, evaluate the evolution. Okay, maybe a 4th generation makes sense here. And the offspring diagram looks now different. You have here the best solutions here, then the next steps and the best individuals. Now I have 177, 22, 75, 80. And these values you can set in your simulation. Okay, I need to write it down. 22, 75, 80. Okay, it's set already. 75, 80. And we need to come between 40 and 45 joules per hour. I take the type statistics and I'm 40.9 throughput per hour. Okay, this helps you to create successions for your production system. And range allocation means you change a value between min and max. This means range allocation. I had another webinar for order optimization with GA. You can also change the order of entries in a table with GA. This is another kind of genetic algorithm optimization in plant simulation. And this you can use, for instance, to optimize the Perl chain of a production, the order of orders. If you have an order management system, you can try to change the order of the orders to create maximum output of a production. Okay, that's it. Any questions? This is a short one today. I said, okay, only some lines of code.
There's actually quite a few questions in the chat.
Okay, I try to find the chat. Oh yeah, so, okay. Is the number of experiments determined by the user or experiment manager? Okay, if you use the experiment manager, you would define the number of experiments. If you have a multi-level experimental design, so it depends on the iterations you want to do and the observations per experiment, and then it's combinatoric. I don't know it in English. Then it creates all possible combinations of all values. If you have between 1 and 100 and 3 parameters, then you have a lot of statistical possibilities how you can combine this, and this the experiment manager creates. And at the end, you have a lot of experiments here, for instance, 1 million. And if you have 5 observations per experiment, then you have 5 million experiments you have to do. And so the experiment manager creates the experiments. I hope this was the answer. Do you activate the increment variant on reset in the experiment event control? You don't need. If you use the experiment manager or the GA wizard, then each replication will be done with another random stream. So you don't need to change the setting here in the event controller. Oh, difficult. Once the experiments have started running, is there a way to interrupt or stop the GA optimization? You can stop it, but it takes a while because I guess it calculates the complete generation to the end. So it takes a little time. The front Pareto. Oh. This is different distribution. I don't think so. Is there a way here shows the front Pareto? I don't think. I don't know. What happens if the contrast between the optimal value and the non-optimal values is not significant? Okay, not significant. It calculates with, I guess, it's 16 numbers, 16 digits, and so you can also make optimizations with very small values. But if you don't have, I had such cases here from students, if you don't have differences between the simulation runs, then it's finished quite fast, and it doesn't run the simulation at the run the optimization to the end. So it just stops if we don't find differences between the simulation runs. And so something needs to happen. For instance, if you change only the buffer capacities, but you don't have any stochastic behavior in your model, no failures and no breakdowns, nothing, then each simulation run will result the same, will get the same result, and then there's nothing to optimize in this case. So you need some changes between the simulation runs. And so how many the changes, it's really runs with a lot of digits. So the difference can be very, very small. How we can adjust the mutation and crossover probabilities. You can look in your controls, and there you have some ways to program. If you change the individuals, you can program stuff if you prepare the next generation, and so you can do your own stuff in this within the GA wizard. You just need to look controls, and then you have three kinds of controls where you can prepare, change the basic behavior of this wizard. What's the best practice for using GA Wizard to optimize the production sequence in a batch manufacturing environment where different batches may require processing at the same stations across multiple stages? Yes, this is one of the standard. You can find a video in the we had already this kind of webinar. First, you need to define a certain set of orders, maybe 1,000 or 100,000. And then you create a model with all the conditions and links and all the stuff you need. And then you run the optimization, you run the order list. You run an optimization about over the order list with the target maximum throughput or minimum processing time. So you need a fitness value. You need to find one. For instance, how many days it took to fulfill all the orders. This is one way to optimize this. Another would be to minimize costs or penalties, but it's the same statistical value. And then you let plan simulation run a lot of scenarios with different orders of production of your production sequence. And so it's just track your order list on the GA wizard, and then GA wizard will insert the table as optimization value, and then it changes the order and looks what happens. Okay, neue Nachrichten. new in the messages. Multiple objectives. How to stop the simulation? There's here reset, and then it takes a while, and then okay, we can try it. That starts, and if I press reset, it stops. It's just over. If your model is a little bit bigger, then it takes a little time, but you can just press reset and it stops. Does the GA wizard support true Pareto multi-objective optimization, or do I combine objectives with weights? Yes, you can do this, but you can also create a method to calculate your fitness value. At the end, you need one fitness value. How you calculate this, it's your you need to decide. You need this, but the most flexible way is to use a method for calculate the fitness value. At the end, it needs to be one digit. Or you need you use a table, and then you can weight the fitness values. In the same case, it needs to be numbers, and then you can weight these numbers if you have several performance indicators you want to include, and then it's weighting. But all the other and more complex stuff, it's methods.
You know, I'm going to jump in with some announcements. Okay, so this slide that you see here has the link to the Plant Simulation Virtual User Group. So if you're new with us, please click through there, bookmark that. That is where this video will be on Friday. So if you think of a question later, you can also ask that question in the forums underneath the video. And then you can see the animation is showing to click on that button there, which is the follow button. And then that would make a Plant Simulation Virtual User Group on your homepage when you log back in. If you want to receive system notifications, then we show there, you should click the envelope icon and choose every post, which will send you the emails for anything in this area. The only thing in this area are videos for the series. We put in the registration links, opportunities to register to come to the series live, and then people tend to ask questions about these topics. So you can also see on the left, those are live links. You can click through to register for our next meeting on August 19, which will be talking about modeling index tables using transporters and tracks. And then on September 2nd, Steffan's going to take us through what's new in Plant Sim 2606. So you can definitely click there to register for that session. Outside of that, those of you who've been here with us for a while know that we have the Siemens Accelerator Academy, and they have comprehensive education on technomatics, plant simulation. They even have a associate certificate if you're just getting started with these topics. So you can click through there on those and have access to that lessons and learning. And then as many of you know, Realize Live happens all summer. Actually, India should have just completed today. The last one for the summer is China, but if you are Chinese Mandarin speaking, then you can definitely, and you're nearby, you can join that. Otherwise, the on-demand content library is available. So you'll see that in yellow there. If you want to listen in to sessions from Realize Live that happened either in the US or in Europe, they should be there. I imagine the India sessions will be up soon. If you are in Europe and want to go to Munich in October, we are having a Plant Simulation Realize Club. So you can see it's a user meeting similar to what's in the photo there. They're expecting 300 participants. You can also be a presenter. So there's 2 QR codes. The big one is to register, and the small one is to submit yourself as a presenter or speaker. And that is it for me. This is Steffen's contact in the community forums. That's the link there to his profile with all his information on it. And the link for the forums one more time. If you didn't get that, you can click through there and bookmark that. So looks like Osama had another question, and we still have time if anyone else would like to ask before we leave.
Yes, one was, could you please specify the types of decision variables of the GA can accept? Okay, the entrance values should be, it's increment. You need to be able to increment this. And so it's integer data type, and a fitness value could be integer or real, because you need to be able to calculate with this values. If you need another, if you need strings or something, you need to create your own transitions, but you can, I showed this, I guess. Okay, first there's a help. Please look in the help. It's in the wizard. There's a help and help on GA, and then you can read all the topics, and for your fitness value, it needs to be some kind of number. If you want, so this needs to return a number. Otherwise, you cannot calculate with this. And so no Boolean, no strings, nothing, only numbers here. Do you have something related to digital twins and virtual commissioning in the future? Digital twin, hopefully this year with the digital twin composer. And virtual commissioning, it's very hard because you need a lot of soft and hardware, a lot of software, different software, maybe next year. In the future, yes. Okay, more questions. If you have some ideas for new webinars, please post it.
I have another question.
Can you hear me?
Yes.
Okay, so a part of this is beyond GA. A part of GA is like Plant Sim looking to utilize other evolutionary algorithm like a particle swap optimization or other like computational method other than GA, or we're gonna stuck with GA for a while?
Plant simulation is now open with a Python interface, and so you can connect your plant simulation model with all kind of optimization models you can find, or methods you can find in the Python world. And so I don't think plant simulation will develop further elements of this internally. So it's opened the architecture to the outside world. And I guess it's, yeah, it's easier. And so find your optimization in Python, and then you can connect plant simulation with this. Okay.
Well, if there's no more questions, then I think we'll see everybody in the forums. So you can go to the forums, bookmark it, and you'll be able to get the recording there. So thank you, Steffen, so much for another useful
presentation. And thank you everyone for joining us live.
Thank you. Goodbye.
Bye.
Thank you.